Okay, lecture 28, percentiles and critical values. Okay, now something that should have occurred to you doing the examples for the last lecture, they were a little bit contrived. I picked the probabilities very carefully, and I point out here that no z-table can contain all possible z-scores or all possible probabilities because there's infinitely many, right? So sometimes we're going to have to use the closest approximation to what we want that we can find in the z-table. So, for example, find the z-score with an area 0.8734 to its left. So, for example, find probability z less than a equal to, what is it, 0.8734, 0.8734, and I say find a. Well, this is just like what we did last time. Well, except for this little extra twist. So let's go to, certainly the probability is bigger than a half, so I want to go to the positive z-scores. Let's go in and find the area of 0.8734, and that a then will be our z-score that we want, that we can get. So I look for 0.8734, and if I look for it, there's 8729, then we jump to 8749, and we just go from here. We go down, and from here we go up. So there is not a point of 8734. So the closest area I can find is, it'd be that one, right? 0.8729. Closest probability is 0.8729. So I'm just going to say use this. All right. If we had a computer and all this were in a software system in the computer would be able to give us a better probability for exactly a better z-score for exactly that probability. We don't have that capability. If you did, this wouldn't be an issue at all. But for now, it helps us to kind of think conceptually what's going on. We pick the closest area we can that's in the table, and if we use that, if you go back and check, it is what? It gives us 1.14. The z-score is 1.14. So there's our answer that we will give. And of course, that's an approximate answer. It should be what? A little bigger or a little smaller? Well, to grab a little more probability up here than we have here, it's got to be a little bit bigger. So it really is probably 1.14. 1 or 0.8 or something, I don't know. And then, like I said, a computer would get it much more accurately, but our table gives us a pretty good answer there. All right, so that's just kind of a general thing to do when you have an area that you want to find the z-score for, and that area isn't exactly in the table. And that leads in to talking a little bit about percentiles. So you read the definition there. I have that the nth percentile of a random variable is the random variable z, is the z-score that has n% of the total area or total probability to its left. And then I ask the question, why does that make sense? Why does that make sense? If you think of what a percentile is for a data set, it's the data value, roughly, that has n% of the data values below it, right, to its left. And so what we're really looking at is grabbing, if you grab n% of the data, you're grabbing, in a sense, that chunk, that fraction is like the probability of that same percentage of probability, right? If you want the 25th percentile, you have 25% of the data to the left, and that means that if you're randomly grabbing a data value, you have a 25% chance of grabbing data from that section. So it makes sense to think that the nth percentile should have n% of the probability to its left. Okay, and if we were to take this random variable z and somehow generate a huge population of data, we would find that at the nth percentile, 25% of that data, or n% of that data will be to its left. And I have you do, don't I? First off, P25. So let's find, for example, P25. So this means the 25th percentile for z. So I need to go in and find, so must look for 0.2500 inside the table. Correct? Since I want area that is less than a half, I know I'm going to have to go to my negative z-scores. It's on the other half. Up here, this is a good example. You can see it's a generic positive z-score. That certainly has more than half the area. I want to be over here where I have 25% of the area, so I want a negative z-score, so I got to go to the next table. Okay, and so what do? I go looking for 0.2500 in the table, and I find 0.2514, and I go here, it's 0.2483, so it's gone, I've gone below it, right? So it's right in between here, isn't it? And if you do a little subtraction, you'll find that this number is a little closer than that number. So we're going to use 0.2514. And what's the z-score? It's if you looked at it, it was negative 0.67. I think it's negative 0.67, right? Yeah, I have in my notes negative 1.67. No, negative 0.67. So negative 0.67. So P25 equals negative 0.67. And the equals is, it's not exactly right. It's close. Close. We're just off by a little bit. Okay, let's do the next one. I want to find P80 for the standard normal random variable. I want to reuse that term again, not just call it Z all the time, but call it the standard normal random variable so you keep all those terms in mind. What is P80? P80 equals, well, I got to go inside and look up 0.8, right? Which is 0.8000, correct? And if you go inside and look for that, I want that much to the left, so I'm certainly in the realm of positive z-scores. And I look over here and I'm, okay, 7995 is pretty close, and then 0.8023. So certainly that one's closer to just 0.8000. So I will say use area 0.7995. And what do we get? We get that P of 80 is 0.84. Okay? Once I get that area that I'm going to use, I just back it out and find the z-score. All right. Now, I think so now I mentioned I want to introduce the concept of a critical value. I used the term a couple lectures ago, and I'm still not going to define it real precisely here. I'm just going to say that it comes up in the context of particular problems. Okay, so we'll get a clearer definition a little later on. But right now, the way to think about it is to think of it as a critical value is a z-score that corresponds to a cutoff value, a cutoff z-score, such that for everything maybe bigger than that z-score, we're going to call those values unusually large, or it might be a cutoff value way over here, such that everything less than that we're going to call unusually small. So they are z-scores that give us cutoff values. And how do you decide what those z-scores are, what those cutoff values are? Well, you decide that you're going to go out so far that you have a certain level of probability off to your right, or way over here where you have just a certain level of probability off to your left. Okay, if you make a small probability, require that the z-score that's the cutoff value be such that it has only a small probability to its right, then anything beyond that is unusually large. If you require it to have a small probability to its left, then anything beyond that is unusually small. And it's usually small because the probability is low that we would go that low, right? The probability is very low, very small that we would go that high if we go beyond the critical value there. Okay, so I will leave you to fill in that blank space there with what I just said. And I point out that if you go out here to the right, you have a critical value, and all the z-values to the right of that, I think of those as a tail of values. And the corresponding area that's above, the tiny little bit of area, sliver of area out there, I call that a tail probability or a tail area. Likewise, if you're way over here, you have your cutoff value, all the z-values to the left are going to be in a tail, what we'll call a tail, associated with that critical value. And that area will be a tail probability. And I just like using those terms, the tail of the z random variable along the axis or the tail probability. Those aren't official terms, but I think they're good for understanding a little bit. So with that in mind, I got a little bit of notation for you. To indicate a critical value that is the z-score with alpha, area alpha to its right, we write z sub alpha. And why do I use the letter alpha? That's standard in statistics. So I'm just kind of following convention here so that you won't be surprised later on. So if I want to indicate the z-score that has a small amount of, usually small amount of area alpha to its right, I will write that z-score as z sub alpha. So for example, let's find z sub 0.05. So example. Find z sub 0.05. What do I want? I want the critical value that has (5% of the area to its right. This critical value we're calling z.05. And what is that critical value? The symbol for it is that, but we can figure it out, right? I now know that to get it, how am I going to get it? I'm looking for a certain area to the right. I need to figure out the area to the left in order to use my chart. So the area to the left is 1 minus that area, so it's 0.95. Let me go to my chart. And what do I have? I'm looking, so certainly I have a positive z-score, so I'm in the right half of the chart. And I want 0.95. So what do I have? I have 0.9495 and 0.9505. So it's really right in between. There's an asterisk there on this chart, and if you follow that chart out, it gives you the z-score, because this actually turns out to be a very important critical value. And if you look, it's 1.645. If you're using a chart where you don't have that, then you have to choose between this one here gives you 1.64 and this one over here gives you 1.65. Neither one is closer, right? So which should you use? Well, you can use either one, but if you have this chart, then you can see that it leads you right out to 1.645. So that's the answer. Next one, find z of 0.025. So find z sub 0.025. All right, it's almost the same picture, right? It's almost the same picture. It's just that now, I'm going way out here, and I only have area equals 0.025. And I just ran off, but it's 0.025 right there, correct? So this is z. This z-score here is z 0.025. What am I going to do? I'm going to look up this area. And you should be able to get that that's 0.975, right? And once again, I look at my chart, and how close can I get to 0.975? And I think we hit it on the button, 0.9750. So there's one where we happen to actually hit, and it's 1.96. So we get 1.96. Okay, when you work these through, you might need to write a little note at this point. Now go to chart, get z-score. Correct? I didn't write that down here. I don't want to have to keep writing and erasing. But you don't also want to have to keep referring back to the video, right? You want your notes. The whole point is when you get done with the video, you have a great set of notes that you can read. So if you look at this and say, okay, how to go from there to there, you better write a little note that reminds you. It's the same thing we did up here. It's the same thing we've been doing when we have, when we find an area, we got to go to the chart inside and go outward to get the z-score. Okay, so make sure you have sufficient notes, because otherwise you're going to have to keep going back to my video all the time when you should have your notes telling you what you need. Okay, what about z sub 0.005? I will leave you to do that one. And next page, what about negative z.03? There's nothing special about this. So I'm leaving the one at the bottom of page 2, I guess, for you. Find negative z.03. There's nothing tricky. All you do is you first find z.03. It's the z-score that has 0.03 area to its right, okay? And that means I need to find the z-score that has 0.97 area to its left, correct? So I come back over here and I look for 0.97 area, and I have 0.9699. That's pretty good. 0.9706, that's over more than this is under. So let's pick this one. So that says 1.8 up to 8, 1.88. So that's 1.88. So my answer is just negative 1.88. And what does that represent? Let me rub this out because I want to say something. Well, let's think of what it means here. And think of it in terms of the symmetry of the graph. Okay, the first one, if I just have positive z.03, that's the z-score that has 3% of the area to its right, and we got 1.88. If I flip that around and take negative 1.88, what I've just found is the z-score that has 0.03 area to its left, correct? That tells you that really, I could have done this a little quicker. I could have just thought, oh, if it's negative z.03, and this can be a little bit confusing, you don't need to do this, but if it's negative z.03, let me just go find the z-score that has 3% of the area to its left. And if I look in the negative z chart, 3%, 0.03, 0.03, okay, the closest I can get is 0.0301, and look at that, it's negative 1.88. I get exactly the same answer. So that's perfectly okay. If I got a z-score that's positive, if I got a critical value that's positive, I'm looking at area to the right. If it's going to be a negative critical value, I'm looking at area to the left. And I can, to get the one to the left, I can compute it to the right, get the answer, and then negate it, which puts it over there. Or I can just start over here and get the area to the left and get it directly. With that in mind, you should try negative z sub 0.1 and see if you can do it both ways, all right? See if you can do it the first way, which is to find just z sub 0.1, get an answer, put a negative sign in front, that's your answer. Then go back and say, let me see about looking for the z-score that has 0.1 area to its left, because that's what it's going to be over here, and you should get the same answer. Let's stop there. Yeah, okay.